Before we go on to explain the mechanism of AV nodal reentrant tachycardia, we need to look at the structure of the junctional region in a little more detail. Atrial depolarization is conducted into the AV node by a specialized tract of conducting tissue. In 90% of individuals, this tract is singular. 10% of subjects, however, are born with two tracts leading into the node, and crucially, these tracts have differing electrical properties. One depolarizes and repolarizes at a normal rate, while the other transmits depolarizing current abnormally slowly, but repolarizes abnormally rapidly. A situation such as this, where two conducting tissues with differing electrical properties are in communication within the heart, is the basis of all reentrant arrhythmias. This situation is an accident waiting to happen. To explain why, we will focus in on events in the region of the AV node during the cardiac cycle. This close-up of the junctional region shows the two tracts leading into the AV node through the surrounding non-conducting tissue, shown here in black. The diagram also shows the proximal portion of the bundle of His and a small portion of the atrioventricular septum. Depolarization will approach the node from the atrial myocardium above. During the normal cardiac cycle, the SA node discharges and the depolarizing current generated travels through the atria to reach the region of the AV node. We will now slow down events at the node to aid comprehension. Depolarizing current enters both the normal and abnormal tract. The depolarization wave is transmitted through the normal conducting tract at an appropriate rate and depolarizes the node. Atrial depolarizing current has also entered the abnormal tract and begins its relatively slow journey through this tissue. However, at this point, current flowing in the normal conducting tissue has already reached the distal end of the abnormal strand and is conducted in a retrograde direction into this tissue. The two currents in the abnormal strand meet at some point and obliterate one another. The small, short-lived currents in this tiny strand of abnormal tissue are not detected by the ECG machine, so absolutely no abnormality is detected on such an individual's resting ECG in sinus rhythm. Following these events, the normal tract goes through a normal period of repolarization, while the abnormal tract repolarizes rapidly. With the heart in normal sinus rhythm, this process is repeated with every sinus discharge, and the existence of the abnormal tract has no consequences whatsoever for the subject. However, if the individual experiences a premature atrial ectopic and atrial depolarization reaches the tracts at this point, the effect can be dramatic. The ectopic discharge has arrived at a time when the normal conducting tissue of the node is in a state refractory to the transmission of current. The abnormally rapidly repolarizing tissue of the diseased section, however, permits current to pass. Now, the slow passage of current through the abnormal section allows enough time for the normal tract to repolarize, and current arriving at the distal end of the abnormal tract is propagated not only into the AV node and into the ventricles, but also in a retrograde direction by the normal conducting strand. By the time the current reaches the proximal end of the normal tract, the rapidly repolarizing diseased section is ready to conduct again. In this way, a cycle of circulating current is established. In the small area of the junctional region, the combination of an unfortunately timed atrial ectopic and the existence of conducting tissues with opposite electrical properties has established a rapidly discharging, self-sustaining reentrant loop of depolarizing current, which is discharging distally into the ventricles via the bundle of His, and also in a retrograde fashion into the atria. This is a micro reentrant circuit occurring over a small area, and the small currents involved have no influence on the resting ECG. As the current is transmitted to the ventricles by the bundle of His, during such an attack we see a tachycardia with narrow QRS complexes. In addition, rapid retrograde depolarization of the atria is occurring, overriding SA node discharge. AV nodal reentrant tachycardia generates a heart rate greater than 130 beats per minute, and often much more rapid than this. In a junctional tachycardia arising secondary to a focus of increased automaticity, the rate tends to lie between 100 and 140 beats per minute. Note therefore that with tachyarrhythmias arising in the junctional region, the heart rate allows us to make an assumption about the mechanism generating the arrhythmia. A tachycardia originating in the junctional region with a rate greater than 140 beats per minute is certainly AV nodal reentrant tachycardia, while if the rate is less than 130 beats per minute, the tachyarrhythmia is labelled junctional. You will appreciate that there is a grey area. Rates between 130 and 140 beats per minute may or may not be due to a reentrant mechanism. As we'll see in the quiz section, whether we label such an arrhythmia as AV nodal reentrant tachycardia or junctional tachycardia is largely determined by the clinical context, and a definitive answer may require further investigation. The second doctor the young lady in the case study consulted spotted all the signs and made the correct diagnosis of AV nodal reentrant tachycardia. The clinical history of paroxysmal episodes is typical, and a normal resting ECG is expected. In addition, the doctor noted on both the 12-lead ECG obtained during the attack and on the patient's monitor the presence of small slurred S waves in lead 2. In fact, these are pseudo S waves and represent P wave activity as atrial depolarization is spreading upwards from the junctional region and is occurring after ventricular depolarization. The complete absence of S-wave activity in lead 2 in the pre- and post-attack ECGs supports the contention that these are indeed pseudo S-waves. As we've seen, this pattern of atrial depolarization supports the contention that the abnormal depolarization focus is junctional in location. At a heart rate greater than 140 beats per minute, the nature of the depolarizing focus within the junctional region is reentrant. This tachyarrhythmia is AVNRT. It is also worth noting that the readout from the patient's monitor captured the moment of transition from sinus rhythm to tachycardia and is very telling. Freezing at this point, we can clearly identify the premature atrial ectopic which triggered the arrhythmia.